to get also x times y, which is I don't have. So what I need to do, I need to create a columns because I don't have the value of x squared. So that's mean I need to get this value of x times y, and I need to get the values of x squared. So x times y, that's mean 1 times 0 0.5. So 0 0.5. 2 times 2.5. So I get the values. 3 times 2. 4 times 4. 5 times 3.5. 6 times 6. 7 times 5.5. Okay. Again here, I need to find x squared. So this is going to be 1. This is going to be 4. This is going to be 9, and so on. Okay. So now, if I'm looking at the slope here, I have n, which is the number of the points. How many points I have in here? 1, 2, 3, 4, 5, 6, 7. So n is equal to 7. X and y, yes, I have. X, yes, I have. Y, yes, I have it. X squared, yes, I have it. The summation of x squared, yes, I have it. Okay, so since I have it now, so what I need to do, I need to find the summation of all these values. So I need to find the sum of the value of x, which is 28, sum the value of y, and the summation of x times y, and the summation of x squared. Okay, so I have those values. Good. So now I need to find here for this one, I need to find the mean of y and the mean of x. So I need to find the average of this. So the average is the total number of the points over the number of the points. So this is the average for x and y. So now I have now all the values that if I put it inside these two equations, I will get the intercept and I will get the slope. So using these two equations in here now, I can find the values. So if I put the values here, I will get my slope is equal to 0.839 and my intercept is going to be equal to 0.07163. So in my case in here, if I'm going to write my what do you call it, my equation, because I have the intercept, I have my slope. So this is the slope and this is the intercept. So my equation y to make the model is going to be equal to the intercept 0.0714 plus 0.839 with the value of x. So this is the equation to make for me the model for the straight line. This is the one. Okay, so this is the example. I want you to try it. If you have any questions, please ask. Then I want you to do the exercise by yourself. You have any question?
No, sir.
Okay, try the example first. Take your time. I will give you about 5 minutes. Try to do it. Then I want you to do the exercise by yourself. Okay, did you get the answer? Did you get the answer? Okay, so to draw the line, you can just choose any points of x. Let's say that is x is equal to 1. Just put it here for this equation. So you're having the value. So the value is going to be here. Choose, let's say, x is equal to 7. So you put 7 here. So the value is going to be showing you at this point. So you can draw the line by connecting the two dots. So this is the model. This is the value of the model that it's making for you the straight line. Okay, this is the exercise. I want you to do the exercise. So your answer is, you need to see this is your intercept. You get the answer of 1.535, and this is your slope. It's 4.1071x. And this is the line that you're going to draw. So try to get these two values. Give you about 5 minutes to get the answer. Okay, so do you get the answer here? Did you get the model? Make the line? Okay.
So yang R22 stand for what, sir?
This is what I'm going to explain now. But if you get the values, if you get the same exact values, I will explain what does this R mean. What you mean? Is it wrong, or you still need the time? Okay, so let me check here. Okay, this is the answer. Maybe your values here is not correct. You check those values. Or maybe your n, it's supposed to be your n. Which one is wrong? Yeah, but it's maybe your calculations for any values here is wrong. Maybe your making summation is wrong, or the means is wrong, or n is equal to 6, which is actually n is equal to 7 here. It's supposed to get these two values. Anyone get the same exact value?
Yes.
Okay, so one of your friends here was asking, what's the meaning of the value of the r square in here? R square here, it's the coefficient of the determination. Okay. The value of r square, if this value is equal to 1, that means it's your line, or the line it's considered it's 100% perfect fit if it's more closer to 1. And which is actually, it's clear, we can see it. If you compare this figure with the previous figure, what you can see from here is the previous figure, the value of the r square is 0.8. Okay. And when you are looking here, you look at the values or the data, the line is not closer to the values. There's a distance between the dots and between the line. So this means the error, it's huge because the line is not closer. But if you are looking at the exercise, the dots, it's almost near to the line that you draw. So that's why is the r square, or the coefficient of determination, it's really high. It's more closer to 1. So the more closer to 1, the more it's better your best fit. Okay, so now you understand what does it mean of r square? Okay, but actually we are going to learn how to get the value of r square manually. This is our target. Okay, so now let's see how you are going to quantify the error. To quantify the error of the linear regression, which is, this is what I'm saying here, how to get the error, which is the distance between the dots and the line, how this one you get the error, how to quantify it. So recall that is, we are saying it's the sum of the square of the residuals, deviations of the regression line from the actual data, which is given by this equation. Remember, it's the error, it's equal to the model minus a naught minus the slope x. But this one here, we are getting the sum of the square of the residual. So that means we need to square these values. And we need to get the sum of it. Okay. So if this is your regression line that you draw, and this is the model to make it. So the error, it's actually is the distance between the measured data and between the model. So this is considered is the error. So here we square it. We call this one is SR, the sum of the square of the residual. So the square of the residual represent the square of the vertical distance between the data, and between the measured one. So this is your data and this is the measured one. So this is what we call it is the SR. This is how we are going to quantify the error. So the analog can be also extended to further cases to see if you want to quantify the error. You want to look how the data is going to be spread points around the line, and how is the distributions of these points with the normals. Okay, so in our case in here, like, you want to see how is your data points, it is scattered around the regression line, how they are looks like. Okay, so there is a way that it will help us to measure those statistics. So the statistics formula may be used to quantify the error associated with the linear regression is going to be like ST and the SR. This is the sum of the square. This is the sum of square of residual around the mean. SR, this is the sum square of the residual around the regression line. So this is how to calculate. So we need to calculate this, and we need to calculate these values. Okay. So SY, this equation here, this is standard deviation. This is quantifying the spread of the data around the mean. SYX, this is to show to us is the standard error of estimates. This is to show how is our data spread around our regression line. Okay, so we need to calculate all these one, ST, SR, SY, and SY over X. So all the equations, no worries, no need for you to memorize. All this equation is going to be given in the exam. Okay, so at the conclusion of when you are making any curve fitting, there is many things that you need to calculate to check how good fit of your line. So the first one, you need to determine the total sum of the squares around the mean, around the average, ST, which is coming by this equation. Okay, sum of the square of the residual around the regression line, SR. So I need to use this equation here. Okay, and the difference between the two quantities of ST and SR quantifies the improvements of the error reductions due to describe the data in terms of straight line rather than the average values. So ST and SR, of course, these values you need to calculate for the SY and SY over X. But the most important things that you need to calculate is the correlation of the determination R square. This is the value that is going to give you the judge of your straight line is it best or not. Okay, so how to calculate the value of R square? R square is equal to ST, sum of the square of the residual around the mean, minus SR, sum of square of residuals around the regression line over ST. Okay, if you are going to say if your R square is equal to 1, so this means we are explaining here about like 100% perfect or the variability of the data. Okay, so you can see it from here. For the perfect fit, for a perfect fit, SR is going to be equal to 0 and R or R square is going to be equal to 1. Same like I show you for this example. The data here, it's almost near to the regression line. So your value of R square, it's 0.98, almost equal to 1. So this is considered best fit. But now I want to ask you a question. Here it says for the perfect fit, SR is going to be equal to 0 and R square is going to be equal to 1. So if R square is equal to 1, why SR is going to be equal to 0? Can someone answer me this question? If someone has answered this question, that means you really understand what I was talking here since morning. If R square is equal to 1, why SR is going to be equal to 0? When SR is equal to 0, SR actually is what?
Error.
It's the error, right? Correct. So why when R square is going to be equal to 1, the error will be what? Okay, it seems like you don't get it, but never mind. Some of you from previous semester, they could answer this. Okay, remember this slide? This slides here, we are saying that it's the best strategy for the curve fitting that you need to minimize the sum of the square of the residuals between the data measured and between the data. From our example here, if R square is going to be equal to 1, so that's mean my data is in somehow something like this. and my regression line is exactly passing on top of the points. So this means there is no distance between the measured data and between the outliers. Okay, so this means like for our example here, most of the points is going to be on the line. So same like in here. If r square here is equal to 1, so that's mean you are going to see that all these blue dots is going to be exactly on the line. So that's why is SR square is equal to 1. And you remember that the value of SR square is equal to the error. So y the model minus A0 minus A1x square. So that's why here, if r square is equal to 1, your value of SRs is going to be equal to 0. Okay. So now let's try to our first example. This is our first example we built to say that we need to get the model. We already got the model. So now how we are going to get the value of r square? We need to get the value of r square. So repeating the same example, we already have the model. So now we need to determine the total standard deviation, standard error of estimates and the coefficient of correlations for the linear regressions obtained in example number 1. So we need to get those values. So you need to get the value of ST, SY, which is how is the data standard deviations around the mean, SR, the sum square of the residual around the regression line, SYX, how is the data scattered around the regression line, and the value of R square. So what we are going to do, okay, so for our first example here, we need to find the value of SY. So the value of SY is equal to ST. So how to get the value of ST? ST is equal to Y minus the Y mean. So this is Y. For 2 and square the value. So you get the answer of 0.862. So 2 minus 3.42, square the value, so you get the answer of 2.04. So this is how to get the value of ST, and this is the sum of it. Okay, how to get the value of how the standard deviations around the regression line? So it's y over x. So we are using this equation here. To use this equation here, I need to get the value of SR first. SR first is equal to the sum of model minus A0 minus A1x and square the values. So this is the answer how you are going to get the value of y 0.5 minus the value of 0.07 minus the value of A1 0.83 times the value of x1 and square the values, you will get 0.168. Okay, so for the second value, 2.5 minus 0.0 minus A1, which is 0.8, times the value of x, which is 2, square the value, you will get the answer of 0.56. So you are going to get the answer of SY over X. So it's equal to 0.77. So at the end, you need to get the value of R square, ST minus SR. ST is equal to 22.7 minus 22.99 over the value of ST. So you will get the answer of 0.86. Okay, try to get those values. Using those equations to get the answer of the value of R square. If you have any questions, please ask. Okay, this one is actually is the example from the textbook. What we can do here, instead of you are doing the example and we are wasting your time, and the solution is already here at the slides, can we do it for the exercise? This exercise is same like the example too. So that's mean those values here, you already got the model for them from this example. You already have the value here. You already solve it. So you already have the model, you already have the A naught, and you already have the A1. So could you please continue to find the value of R squared and Sy over X and Sy, and find the St. And I will show, and I will compare your answer. I will give you about, like, let's say about 10 minutes. Try to solve the exercise, and I'm going to show you the answer for it. What you need to do is you need to follow this way, but use the exercise, use the value from the exercise. Yes. So this is the answer. You can see it here on the screen. Okay, so that was the exercise. Okay, so last thing for today, it's a linearization of non-linear relationship. Most of the time, or most of your engineering function, it has non-linear relationship. So this function, you cannot describe it using a line, especially if you're having like exponential equation, power equation. Those equations, actually, they are giving you a curve, okay? They are not giving you a line. So that's why if your function actually it's giving you a curve, so it's going to be really difficult to describe or to get the value of r square high using a line. So what we need to do in this case? So what we need to do for the type of non-linear relationships function, that we need to transformation, or we need to transform it to fit with the, to be compatible with the linear regression. So example of your functions that can be linearized. So exponential equation, we can convert it or we can transform it to be a line, power equation, and also saturation growth rate equations. So this is the three equations that we can linearize them. So how actually we are going to linearize the linearization? Let's take for example, this is an exponential equation. This is the power equation. This is the saturation growth equation. So you can see from all the time, those equations, they are giving you a curves. They are not giving you a straight line. So how we can make those equations to be equal to the line? This is how we can linearize them. This is how we can transform them. Okay, so to linearize them, it's also depends on the slope and the intercept. So you need to calculate the slope and the intercept for those three equations. So you can see if you are having an exponential equations to linearize them, so you need to use ln. So ln y is equal to the slope and ln of the intercept. This is how to linearize. If the equation is a power equation, to linearize it, so you need to use log. So you're using log. So you need to log the value of x for the slope and log the values of a2 for the intercept. Okay, if you are having saturation growth, so it's going to be equal to 1 over y. So this is going to be equal to, this is your slope, and this is your intercept. This is the way how we are going to linearize. Okay, let's take an example of, let's say, power equation, and you see how we can linearize. If you have a questions or example is coming as a power equation, how you are going to linearize. Okay, this is the example. It's asking us to fit the power equation to the data table using the log transformations of the data. So since this is a power equation, so I need to get my function that is going to only to linearize. So I'm going to transform it from this to be a line. So the example when it's coming is having the values of x and the values of y. So let's see how to do that. Okay, let me hide this one first and hide this first. Okay. So when the question is coming, you're having two values of x and y. I have 5 values, so n is equal to 5. So since this one is a power equation, and to transform it to be a line, so I need to log the value of y, and also I need to log the value of x. So this means I need to log the value of x, and I need to log the value of y. So this one is equal log the value of 1, log the value of 2, log the value of 3, and log the value of 4, and log the value of 5. Same you are going to do it here. You will find the logs. Okay. What you do now in here, you already log the value of x and log the value y. Once you log the value of x and y, forget the original values. You are not going to use them anymore inside your calculations. So these values, forget them. This one is going to be considered your x value. This is going to be considered your y value. So now to find the intercept and slope, you're going to use these two values to find the intercept and slope. Okay, so that means I need to find x times y. So I need to find log x times y, and I need to find x squared, so that means log x squared. So find the values. Okay, then you need to find the summation of these values and the mean. So this is x, this is y, this is x times y, and this is x squared. Now these values, you are going to use them inside these two equations to find the answer of, and to get the model that is going to create for you the model. So at the end, your model is going to be equal to log y is equal to 1.75 log x minus 0.g. Okay, so this is how to get the answer of all the model. Try the example. If you have any questions, please do ask. This example in your textbook is 17.4. Okay, do you have any questions about how to linearize? Any question?
Sir, untuk this chapter kan,
Yeah.
kita kena guna handwrite ataupun uh, boleh guna Excel?
No, for final exam, midterm exam, there is no Excel. All is going to be handwritten. Assignments only. The assignment only is going to ask you one question to use Excel and MATLAB.
Okay, understood.
But for final, for midterm, you need to use handwritten. You cannot accept Excel. Okay, so if you go for your future, what you call it? It's the course forum. You can see here week 6 curve fitting, linear regression. I already put some videos online for YouTube, and you can watch for the linear regression. Okay, this is the least square methods. Also, some videos explain about how to quantify the error and also how to linearize. I give you here an example of this one is solution step by step. This Excel file, you can download it and you can see the numbers is like step number 1, step number 2, step number 3. So you can follow to solve for the least square of the regressions. So if you don't have any question, that's all for me today. Remember that it's our next lab. I'm going to continue with the polynomial regression and multiple linear regression, and I will give you the lab for that. So our class is not for long for the lab, but I'm going to cover the whole chapter because week 7 is going to be it's the midterm. So if you don't have any question, so that's all for our class today. For is the same value and the fraction will be 1. Oh, this is the answer of it. Okay, so please write your name and your student ID, and don't forget the group, please.
Sir,
Yes.
nak tanya, kan untuk linearization of non-linear relationship ni kita guna log x tu kan, jadi x tukar kepada log x. Tapi yang dalam contoh yang bergambar tu, kan ada yang graf dia, fraksi dia log 1 per y dengan 1 per x.
Satu kolom Y, satu kolom X.
Yang ada gambar slide yang ada
This one?
tunjuk
This one?
bukan. Yang ada 3 contoh graf serentak dalam satu gambar tu.
Contoh draft. You mean my Excel file, you mean? You mean this one?
Dalam slide.
This is the slide.
bukan. Yang before
Linearization
example
nonlinear, starting
yang slide before
before
example
example
5.
5.
Before. Yang ada graf, 3 graf. Yang ada exponential equation dengan power equation dengan saturation growth rate tu.
This is the one.
Huh? Oh,
This is the one. This is exponential equation, this is power equation, this is saturation growth. What's the question?
oh. Sebab Senang. Ada. Bukan table ni. Ni tu ada gambar dia. Macam mana? Macam graf sini, yang sini macam mana dari Y jadi 1/Y, bukan log.
What's your question?
Yang depan C tu the exist kan before YX, after linearization jadi 1/Y dengan 1/X.
I cannot get what you mean. You're talking about which figure? This figure?
C.
Oh, okay. C. Okay. So what's wrong with it?
I don't understand macam mana dari Y jadi 1/Y that exists after linearization.
1 over Y. You make 1 over Y. So this is going to be your slope. And this is going to be your intercept.
So jadi untuk linearization ni tak semestinya guna log je lah, dia boleh.
No. You are having 3 types of equations. So exponential equation, power equation, and saturation growth. So if you are having exponential equation, you need to use ln. If it's a power equation, you need to use log. If it's saturation growth, so you need to use 1 over Y and 1 over the slope. That's it. Okay. So this is the way.
Okay. Understand. Thank you, sir.
Okay, welcome. Okay, there's another things in here before you leave. At the textbook,
Sir.
you are going to have, since we are having here a power equation we already solved. If you look at the textbook, is problem 17.11, it's exponential equation, and 17.2 is a someone was asking question.
Sir, nak tanya, kan for the assignment kan kena handwriting kan?
Yes.
Okay, what about kalau contoh ada certain yang minta ni kalau dia orang guna tablet application not yang macam not in physical paper tu. Dia handwriting
You
but
mean you are
in app, macam kalau kita guna tablet kita ada apps tu kan yang maksudnya not like physical paper. Dia macam paper maya punya tu yang dalam the, so boleh guna ke yang tu?
It's how is the writing is going to be?
The writing handwriting lah, cuma guna application in the tablet.
Okay, I don't mind. Actually, it's for me, it's I don't care about what's there, but it's because at the end of the semester, all your answers supposed to be uploaded for the EAC. This is people coming from Ministry of Higher Educations. If they audit and they found something like that, it could be a problem for me and for the faculty. So if you promise that you're going to give your answer in the form of handwritten with any way, it's okay. But if you give it in a form of Excel, this is not acceptable because, it's the tools of Excel or MATLAB can give you the answer directly. So we cannot accept that. We are looking for the methods. So you want to see your handwritten, how you solve. Clear?
Okay. All right. Thank you,
Clear?
sir.
Okay. Okay, welcome. So that's all for our class today. If you do have any questions, ask. If not, so thank you very much. I will see you again for the lab. And enjoy your next coming duty. And don't forget to submit your assignment on Friday. Thank you all. Take care.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.